Correct. So last time we had finished AC and we discussed some problems of EMI as well, right? And you guys asked for self and mutual inductance. So we would discuss that also, but before that we would discuss the topic we came here to discuss. That's electromagnetic waves. Now this is one topic in which not much is covered in 12th physics, but it has great applications in terms of communication. You know, these days everything from very small mobile phone to an aircraft, everything works on navigation, on signals, and all of these signals, they are composed of electromagnetic waves. So let's say, for example, in here in this room, it is stormed by electromagnetic waves. It is just that we can see only the visible portion of electromagnetic waves, and only due to that we can make sense out of the chaos. Otherwise this room would be flooded with EM waves, right? We would discuss the nature of different type of EM waves, but first let's discuss how people discovered EM waves. Okay, the first topic is displacement current. Okay, in this chapter we have only two derivations. One is this displacement current and other is energy derivation. That's it. Rest all is not in our syllabus. Continue करता रहूं. Okay, displacement current. So you do remember the Ampere circuital law, right? Which said P dot dl over a closed loop is equal to mu naught I. Okay, line integral of magnetic field is mu naught I. You do remember this, right? So let's consider the scenario through which actually Maxwell proved that this law is not correct in all situations. So let's consider this scenario. This is a capacitor C, okay, and the key is closed at t equal to 0. The connection is made at t equal to 0. So what happens is the charge rushes to this plate as well as this plate. You know this, okay? In steady state, you do remember that in steady state, what would happen is, in steady state, capacitor gets fully charged and current becomes 0. Okay, so if no current, no magnetic field, so the law holds true. Now in this case, while the capacitor is charging, the transient state, we call it the transient state, okay, when the values of current or charge are not stable, right? So let us imagine two Amperian loops. First one is this, okay. I'm shading the surface, okay. So this is the loop, the boundary, and we have an area inside. So we do know that actually the magnetic field here can be calculated using this formula, and you know the value already. We'll calculate it, we'll take care of it later. But you do know also that Ampere law is valid irrespective of the size of loop, the shape of loop, okay, the shape of area in between as well, okay, the shape of area between the loop, the area enclosed by the loop, I should say. So let me first ask this question. In case of a hemispherical bowl, we have a hemispherical bowl, okay, this is the loop, no? We have a hemispherical bowl, except the loop, it doesn't have any edge, it is rounded everywhere, right? It is rounded everywhere, so this all portion is rounded, this is the only edge that it would have. So we can say that this is the only loop we can find in this case, okay. Now in scenario 2, let me just remove the shading from here. Let me just use this hemispherical surface. Okay, let me just use hemispherical surface. So this, the shaded portion, this is the actual surface, but the loop is like this, right? Okay, so now we can see that here if we take dl vector for the loop, in this case we can see that no current is actually crossing the area, the surface of the loop, the surface of hemisphere, right? No current is crossing here, because here I have not shaded the area, I'm not considering this area, I'm considering the hemispherical area, piche wala. Okay, so now since no current is crossing this loop, from Ampere's law we can say that this is mu naught 0, okay, right? P dot dl is 0, and we can say that B would be 0. In the previous case, for the same loop, the area was considered that is in between, okay, the area considered was that is enclosed by the loop. Now this time it's an extended area. Just think about it, a fish net, you know, a fish net pulled backward, or a chai ka filter, exactly like that, right? A chai ka filter curved, but the edge is on the rim, okay. So in this case magnetic field is 0, while in the previous case when this kind of scenario was there, the magnetic field was given by B is equal to mu naught I by 2r. You do remember, okay, considering it as a long conductor. So how is it that the same loop which gives magnetic field as mu naught I by 2r, in case of, you know, this kind of loop with area enclosed inside, it gives magnetic field this, the same loop, while in this scenario the same loop gives 0, right? So you understand now that there is some inconsistency, right? There is something wrong. Unlike the choice of loop decides what is the magnetic field, how is it correct? It's not correct, right? Nature is not like that. A doubt we have. Hemicircle one, okay, someone is asking for the hemicircle part. Okay, I'll explain it. I'll draw two diagrams, okay, so that people may get less confused. One scenario is this, the loop, okay, the loop, and this is the area enclosed by the loop, okay. So a current I passes through this area. So for this loop we can write B dot dl vector is mu naught I, and from this you already know that B would be mu naught I by 2r, where r is the radius of this loop. Okay, okay. So if the area, this area enclosed is penetrated through by a current I, we get this current, this magnetic field. However, let's change the scenario. Okay, same loop. Okay, this time same loop. Okay, but I'm not considering the area enclosed. This time I'm taking this as a hemisphere. This is the area enclosed. As I said, कैसे चाय का फिल्टर होता है ना, you pour tea over it, है ना, it is a hemispherical bowl, but उसका edge, where is the edge? The edge is on the top, like this. This is like it. The edge is here on the top. Okay, so the edge would be considered as the loop. So our loop remains same. However, I change the shape. Okay, now since no current is crossing this hemispherical area, you can't see any current, any conduction of electrons through this area. So in this case, since no current is crossing through this area, we can say that integral B dot dl over closed loop is 0, or B is 0. And we see that these are actually the same loops, only the area enclosed has been changed. Okay, and in Ampere's law, this area enclosed never is considered, right? You do remember that the Ampere's law never spoke about any area term, area enclosed, right? So how can a term which has actually not been considered is changing the values here? For the same loop, if the area enclosed is inner one, then magnetic field is this. If the area considered is this through between the plates, the hemispherical one, then the magnetic field is 0. So you do see that actually there is some inconsistency. The law is not correct in these kind of cases where we considered a hollow space, an area through the hollow space. Right, okay, doubts, huh? So this inconsistency, Maxwell said that actually what happens is this cannot happen. For same loop, magnetic field cannot be different because of two different scenarios when the current is same in both the cases. The problem here is that actually Ampere, he forgot to consider this kind of scenario in which electric field is increasing or decreasing, right? What he did, what Maxwell said, that actually what happens is the electric field through between the plates is increasing. The electric field between the plates is increasing, and due to that we can consider it as a current called displacement current. We'll derive the displacement current value. Okay, so if Q is the charge on capacitor, E is the EMF. Okay, let us say A is the area of plates. Okay, so you do know that electric field is what? Electric field is what? Q by A epsilon naught, right? And we can say that Q would be how much? E epsilon naught. So if I go for the current dq by dt, which is I, it would be AE. Since area is not changing, epsilon naught is constant, the only thing worth considering is this, which means what? That while rest of the circuit was carrying a current I, a conduction current we would call, because it is because of conduction of electrons, this part of the circuit, it actually it actually carries current, which is because of increase of electric field. Okay, we'll go back a little while, a little time. Okay, we'll try to consider the other scenario possible. You do remember there was a topic named time varying magnetic field? Do you remember? Okay, I would discuss a bit of it in the later part. Okay, one or two questions. But in time varying magnetic field, we saw that actually magnetic field change can induce an electric field change. Here an electric field change, electric field is changing, d by dt I said. Okay, so if electric field is changing, it can actually change magnetic field as well, or produce one. You do remember, right? Magnetic field was change, magnetic field change produced electric field. So nature loves symmetry, right? That's Maxwell's statement. So on the basis of this statement, he suggested that actually because of change in electric field, a current has to be considered in this area which produces the magnetic field, right? So while I is the current in rest of the circuit, this much is the current in hmm, this much is the current in the gap, okay, because of the change in electric field or the change in electric flux, right? So this term, this is called displacement current, id, okay, and it is always equal to conduction current, okay, otherwise the continuity would break. From here to here current is I, so if displacement current is something else, the continuity again would break, the same thing would fall, okay. Okay, the same explanation of Maxwell, that would fall again, B would be different. So id should be always equal to IC. Displacement current is always equal to conduction current, right? Okay, chalo, you guys write it if you want to. I'll give just a minute. Shall I continue? At least can I erase this top part? Huh? I just want to consider some scenarios. Shall I start? Okay. So listen. Now we have one region. This is 2. This is 3. So in region 1, current IC, the conduction current exists, which is calculated by a normal means. You do remember that in an RC circuit, the current was what? I is I naught e raised to power minus t by tau. Do you remember? Yaad hai? Huh? So this would be the conduction current. So what would be the displacement current then? The same value, right? In scenario 1, in portion 1, conduction current would be this. In portion 2, same would be the displacement current. In portion 3, same again the conduction current, right? And what if the capacitor gets fully charged? If the capacitor gets fully charged, conduction stops. Okay, when conduction stops, charge on this becomes constant, electric field becomes constant, so displacement current stops. Okay, it becomes 0. So it becomes 0 as soon as the thing, the conduction current stops. Okay, what about an AC? Would it be same in AC as well? What if we apply an AC here? It was one of the question asked. It is not a topic asked in JEE Advanced, so it has been asked in JEE Mains. Just 1 or 2 questions have been asked, while in other engineering entrance exams, some questions have been asked only on these two topics: the displacement wave, displacement current, and the energy density. And the third topic is spectrum, which I won't teach actually. because it's, you know, Rato. So what about an AC? What if an AC is applied to a capacitor? Okay, what would happen? Would the displacement current be same in this case as well? Huh? Capacitor block karta current. Okay, let's discuss in this case. You know, XC is 1 by omega C, right? You do remember. Okay. So conduction current, sorry, conduction current would be E naught by E by XC. Okay, clear? The conduction current varies. You know, you do remember that there is some phase involved as well, pi by 2 phase. Okay, I'm not going back into that. That had been discussed in 3 consecutive classes. So the only thing I would say is there would be some phase involved. However, you know, the current deposits charge on the plates. So the charge would also follow some sort of sinusoidal function, even though a phase would get involved, dq by dt factor. Okay, some dq by dt factor would get involved, and due to that, this would be E by x c, and so q would be some E by xc dt integral, but which would have some different phase as compared to I. Okay, a factor of pi by 2 here and there. But you know, this is EMF, E naught, E naught. Okay, but even in this case, you do remember that electric field would depend on Q. Again, the same logic. So would the flux. So phi would depend on Q as well. And here also we are taking the derivative. So what we are doing is, to calculate Q, we are integrating. Then to calculate displacement current, we are again differentiating. The thing remains the same, right? Okay, so no phase involved as well, which means that displacement current would be same as conduction current, even phasor form में. Is it okay? Is it okay? पूरा scenario समझ आया? That what is happening is, a current, conduction current flows which is out of phase, 90-degree out of phase with the supply voltage. Okay, because of that a charge gets stored which is again out of phase with current, 90-degree ka factor again, because sine ka integral would be cos and so on. But again what we need to do is we need to differentiate the flux. Flux was proportional to charge, q by epsilon naught, you do remember. Okay, flux is q by epsilon naught. So since flux is proportional to charge, we would be differentiating flux, we would be actually differentiating charge itself, and in place of charge we would be placing the same conduction current. So घूम फिर के बात वहीं आई, what, even in the phasor form the conduction current and displacement current would be same. So that means they would have their maximum values, their peak values at the same time. Okay, so they would always be equal. And it was a question asked that displacement current and conduction current are equal in AC, in DC, in AC as well as DC, and none of these. So the answer was in AC as well as DC. However, apart from this, a little line of difference, phi, sorry, B due to IC is generally a lot more as compared to B due to displacement current. Okay, it is always generally more than B due to ID. Why? Why? I'll redraw the diagram. This time I'll take circular plates for capacitor. Like this. Okay, T equal to 0 पे connect किया. the field here due to conduction current would be, you know it, okay, okay, but the field in between the two plates would be lesser. Why? Because this current is carried by a thin wire. However, the current carried between these two plates, the displacement current is distributed over whole of this area. So because of this, the field inside anywhere would be low, lesser. Okay, and it's time, I guess, to take our first question. दूसरे वाली शीट, इसका बैक साइड. क्वेश्चन 1, थोड़ा ब्राइटनेस थोड़ा कम हो जाएगी. ओके, बिकॉज ऐसे तो कुछ दिखेगा ही नहीं. मैं आज ब्लू पेन से लिख के रहा हूँ. The first question, actually, if it is visible, I'll read it out for you. A charged parallel plate capacitor has circular plates of radius, actually, some area गलती से लिख दिया. Charged capacitor, a charged parallel plate capacitor has circular plates of radius 5 centimeter. Okay, this is the radius of plates of capacitor. Okay, now it is being charged so that electric field in the gap between plates rises steadily. So electric field increases steadily. Okay, at the rate of 10 raised to power 12 volt per meter second. Okay, find ID. It's an easy question. Find ID. Online people, anyone? Tell me. ID would be what? Epsilon naught d phi e by dt, or epsilon naught pi r square is the area of the plates, okay, into dE by dt. You know, phi e is E into A, electric field into area. Okay, so this would be 8.85 into 10 raised to power minus 12 pi into 5 into 10 raised to power minus 2 square into 10 raised to power 12. So the answer would be how much? Kandasa? You do remember that 1 by 4 pi epsilon naught is, let me write it here, 1 by 4 pi epsilon naught is 9 into 10 raised to power 9. So 1 by pi epsilon naught, or I can say pi epsilon naught would be 1 by 36 into 10 raised to power 9. You can use that directly. I mean, the values would be a little easier to handle. You would handle pi as well as 8.85, or you can directly multiply as well. That's your choice. आंसर नहीं आया. into a into 10 raised to minus 1, something like that. So 2 by 3, around 0.07. Okay, around 0.07 ampere. Okay, and the second one is also for displacement current. हाँ 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 मैं read कर रहा हूँ, that's why. अच्छा, so okay, second question I would like to read, actually it's not really visible. A capacitor initially uncharged is connected across a voltage source. ठीक है, a capacitor initially uncharged is connected across a voltage source of EMF E naught through a resistance R. Okay, find displacement current ID. That's it. Okay, the question is as simple as that. Find displacement current ID. And I am erasing it. Anyone answer? Online? No one? No one? Still no one? Huh? I'm shocked actually. We discussed it, right? Yeah. You have to find displacement current, right? It's not mentioned at what time do you need to find. So it should be a general function, right? So it's a kind of scenario like this. A capacitor connected through a resistor to a battery. This is resistance R, capacitance C. Let's say this is connected at t equal to 0. Okay. You know the charge flows in this case. Okay. The charge as a function of time is given as minus t by tau. You know, tau is what? Time constant. Value याद है? Okay. ठीक है. अच्छा ये are you guys shady about it? Not really comfortable about it? Huh? This topic comes back in LR circuits as well, right? So, so current in this case would be what? Conduction current. dq by dt. You can calculate, actually it would be C E naught. How much? E minus t by tau upon, this is minus sign, minus 1 by tau. Sorry, we are differentiating, so minus 1 by tau. Okay. Is it okay? So C E naught E minus T by tau upon RC. E naught by R, which is the maximum current in this scenario. Final steady state current, okay? I naught E raised to R minus T by tau. This is the conduction current. And we just now discussed that actually displacement current would be the same, exactly same. And I had already discussed that even before the question I had given you a hint. अभी हुआ था ना डिस्कस थोड़ी देर पहले just I discussed this case with you. So displacement current would be same. Okay. Shall I erase? Let me start erasing with the let's have a question on the board. Okay, I had two questions in the sheet actually, but since you guys are not really comfortable with this, I'll give one more question on the board itself. Okay, so I'm erasing this. Done. This is a capacitor. Okay, an open capacitor, open circuited. It has a charge. It is charged to a voltage of V naught. Okay, it is charged to a voltage of V naught. V naught, let's take it as 100 volt. The capacitance, let's take 1 microfarad. Okay, okay. So now area of plate is 1 centimeter square. Okay. The question says due to ionizing radiation, comma, capacitor loses charge at the rate of let's take it as 0.2 microfarad per second. So find ID. Okay, find ID. Anyone online? एक का तो जवाब दो ऑनलाइन वाले लोगों. At least answer this one. No. Let me solve it for you. You are struggling really hard. Just check the rate of charge loss, which is actually what? dq by dt. यही तो होता है ना. Whenever you read a word rate, just think in your mind it's actually a derivative of something. हाँ, oh, accidentally microcoulomb होना चाहिए था. That's my bad. Okay. So whenever you see a word rate, it's actually a derivative. So dq by dt is 0.2 microcoulomb per second, which is actually 0.2 amperes. Coulomb per second is amperes. This is the conduction current or the displacement current, whatever you may call it. Okay, this would flow in what sense? Whenever this is connected, only then, let's say some ionizing radiation is there, due to which charge, either the key is connected or charge leaks through the key. Okay, because we assume that capacitor plates, they are sufficiently apart and charge is not leaking in between, but it can leak through the key. In the lab you have seen the key, right? There is a very small gap between two blocks of metal in which you insert the key. So the charge, the space in between here, the charge leaks actually due to ionizing radiation. So we need not think about all of this. Just only thing we needed to consider was that actually dq by dt is 0.2 amperes. This would be the displacement current, right? कुछ नहीं करना था, सब कुछ, all of this was a trap. The values were trap and you guys got trapped. Glad. Shall I continue? Okay. Now the next thing we would discuss is an EM wave. What an EM wave exactly is. Okay, before EM wave, I would like to write the Maxwell equations. Okay, they are fundamental equations or all the fundamental laws of electricity and magnetism. Okay, the first is Gauss law in electrostatics. Gauss law in electrostatics says E dot ds vector is q by epsilon naught, which is inside actually. Gauss law in magnetism. B dot ds is 0 because no monopoles exist. Next one, any suggestions? Okay, that's Ampere's law modified by Maxwell. And the fourth one? Third one is Maxwell Ampere's law. Okay. Which is B dot dl is equal to what? Mu naught IC plus ID. They don't coexist anywhere. In some part of the circuit, IC would exist, while in other part of the circuit, ID would exist. Okay. Okay. So they won't be non-zero together in a part. There would be 0 in one part and non-zero in one part, and so on. So this thing would be mu naught IC plus epsilon naught d phi e by dt, right? The fourth law is, do you remember this Faraday law? What? Induced EMF is magnetic flux by dt. Now induced EMF in integral form can be written as electric field dot dl. Okay, and it's generally induced in a loop, so we would be placing a closed loop integral d phi b by dt. So can you see the symmetry? Line integral of magnetic field depends on electric flux, and line integral of electric field depends on magnetic flux. So nature loves symmetry. Okay, proved. Now on the basis of these equations and on the basis of discussions we had, a time varying magnetic field produces an electric field, However, a changing electric field produces a magnetic field through Maxwell Ampere's law. Okay, so what if at a place the electric field changes? Let's say initially electric field changes and it changes continuously, due to which a changing magnetic field is produced. Okay, that changing magnetic field would further produce an electric field which would itself change. Let us say at any place the electric field is of this kind, something omega t. Okay, a sinusoidal electric field. This would produce a magnetic field which would be again sinusoidal in nature, right? A sinusoidal magnetic field, because a changing electric field would produce a magnetic field, okay, which is calculated through an integral, okay, a derivative and an integral. So the terms sine and cos, they would keep continuing, right? Okay, so this changing electric field would produce a changing magnetic field, which in turn would produce a changing electric field again. Omega would keep coming, the term sine omega t would keep coming. Okay, you can see from here actually, from here flux would be a sinusoidal function. Okay, due to this flux actually v dot dl would be, you know, d phi by dt we are saying. So for this the term here would become cos omega t, right? And cos omega t is equal to integral of this. Okay, so post integral, okay, after integral, if we take, I mean, like, instead of integral, let's take a derivative on in this side so that we get v single out. Okay, so in this case also again we would be differentiating the cos term, which would give us the sine term again, right? Getting my point? What we do is, instead of a integral on one side and a derivative on one side, let's do one thing. We have a double derivative on one side, and sine ka double derivative would give us sine again back. So the magnetic field and electric field would always change in same phase. Okay, they would be in same phase. A changing electric field produces a changing magnetic field, time varying, which would in turn produce a time varying electric field, and this cycle continues. It's kind of a chain reaction, right? Okay, it's kind of a chain reaction, due to which this phenomena continues forever. Okay, so in surrounding regions, you know, a source produces electric field changing, sinusoidal electric field. In surrounding regions a magnetic field is produced, which is also time varying, which is further extended and so on. So in this manner this electromagnetic field, the combination, is transmitted into the space. Okay, and as you know that electric field and magnetic field regions, they do carry energy because of electric field as well as magnetic field. So these electromagnetic fields, the combination, that would carry energy away from the source. Okay, so this thing is called an electromagnetic wave. And you know, since electric field and magnetic field can spread through any medium, okay, vacuum as well, okay, through any medium, so this changing electric field and magnetic field, this chain reaction kind of thing, that this would keep propagating onwards and onwards till infinity. Okay, so this is an electromagnetic wave. However, the only thing worth noticing is that for an electric field, if we form a sine wave like this, okay, the magnetic field is generally perpendicular, so it would be like this. Okay, okay, and the direction of motion is perpendicular to both of them. We'll see in an example, but you know, these arrows, it's not actually happening like this, and the arrows, they don't indicate any displacement of particle, they just indicate the value of magnetic field or electric field. If this one is electric field, this would be magnetic field. They achieve their maximum values at the same time, however in perpendicular directions. Okay, okay, and you know, there is a very detailed discussion of this, which is out of our syllabus. So I'll just tell you the result, that electric field and magnetic field, they are always in ratio of C for maximum values as well as for instantaneous values. Why? Because they always have the same phase. So let's see how exactly is the propagation of wave happening in our case, the displacement current scenario. Okay, so if we join this, if we connect the key, what happens is the electric field increases. It is a time varying electric field, and the magnetic field, which is in the form of circles, it increases. Okay, so at this point, even inside the plates, it is like this. So let's take this point. Okay, at this point, what happens is the magnetic field is inward, the electric field is like this at this point. And what do you think should be the direction of EM wave then? Huh? Perpendicular, like this. It spreads like this. Okay. And since you know that electromagnetic waves, they carry energy, so some part of energy would be lost in the form of EM waves. Okay, that does happen in case of small atomic level transitions and all, but we don't see it in the large scale things, right? Okay, so shall I erase? Also, one more thing, I'll just introduce one thing. I'll not discuss whole of the thing. Let me first erase it. Do you remember in case of time varying magnetic field, even in the case of time varying magnetic field, if this is the direction of magnetic field, this is the manner in which electric field operates. Okay, so if I take this point here, electric field would be like this, magnetic field would be like cross, and the C would be like this, would spread like this. Okay, okay, it would spread along the perpendicular to the circular surface, the curved surface of the cylinder, right? Okay. Acha, what I was discussing here is, let us say an EM wave is passing through this region. Okay, so if we consider a small patch, if we calculate flux through it, let's say electric field is in this direction and magnetic field is in this direction, so electric field would be going up. If we calculate flux through this, okay, and if we put it into Ampere circuital law, okay, again, if we take this loop B dot dl, for this loop, closed loop integral, okay, if we try to calculate this and we take flux, how would we calculate it? We are assuming that there is no conduction current, so only displacement current would exist. So this thing would be how much? Mu naught epsilon naught d phi e by dt. So what we do, we calculate the electric flux through this small patch and integrate it through whole of the region. Okay, then we'll get an expression for B. Again, if we take another patch here, another portion here, and do the reverse, you know, in this case we do E dot dl for the whole loop, but we calculate the magnetic flux. Let's say I have this strip, and we'll get a value of electric field from there. Okay, we get two values. Okay, we can use any of the value to put in any other function. By doing all this long procedure, actually I'm not doing it, I'm just trying to give you a reference how he proved it. Okay, so how he proved it? He used two laws. He used calculated B from one law and put it into another law, the last two of the laws. Okay, the Faraday law as well as the Ampere's law. Okay, calculated value from one and put it into the other one. So what he found was that actually C is 1 by under root mu naught epsilon naught. So this is all we need to remember. For any medium, this would be like this. Okay, and from this we can see the refractive index N. What would be the refractive index? You know, a question came actually of this as well. What would be the refractive index? C by V or under root mu epsilon naught by mu naught epsilon naught. A question came of this. So the topic is itself a little difficult to understand, but the questions are really easy. If you want to write, you can, and we'll have a question here after that. I'll read it out. But first, you guys just those of you who want to write down. Okay, let me read out the question. A beam of light traveling along x-axis is described by electric field. Can I erase this? I think I can. Okay. The question is, beam of light is traveling along x-axis. Its electric field is given by 600 volt per meter sine omega t minus kx. Okay. Okay. Acha, it is, the question is asking the maximum magnetic force on an electron moving with speed 3 into 10 raised to power 6 meter per second along y-axis is, which you need to calculate. Okay. Okay, you need to calculate the maximum magnetic force, which means you need to calculate the maximum magnetic field, right? And you know the relation. It's an easy question, right? You need to find B actually first. Okay. You do remember C is E naught by B naught, right? So B naught would be 600 by 3 into 10 raised to power 8. Okay. So 2 into 10 raised to power minus 6. ठीक है? Okay. 3 into 10 raised to power minus 23. I guess ठीक ही आ रहा है. 3 into 2 है या 3.2 है? 3.2 है. नहीं, थोड़ा सा गड़बड़ हो रहा है. It's slightly wrong. The answer someone has posted. So F maximum would be EVB. E is 1.6 into 10 raised to power minus 19. V is how much? 3 into 10 raised to power 6, and V is 2 into 10 raised to power minus 6. Okay, ठीक है? Cancels. So 6 into 1.6 is 9.6 into 10 raised to power minus 19 Newton. Okay. Okay. So same question can have many variations. I'll discuss. Okay, I'll discuss them. Can I continue? Shall I? Okay. What happens if the electron, in this case, the electron is moving along electric field. Okay. The electron is moving along electric field. So we for sure know that actually magnetic field would be perpendicular. Okay, it is perpendicular to electric field. We don't know exactly is it outward or inward. Okay, okay. But however, the question change its the situation. The electron is now moving along. Okay, sorry, I assumed this direction to be y. It's okay, works. Okay, the electron is now moving along x-axis. So the electric field would be parallel in this case. So the maximum value would come out to be how much? 0, because it is parallel, right? Getting my point? What happened in this case was electric field was perpendicular, was in y direction. Electron was moving in y direction. Okay. So we for sure knew that magnetic field would be either in this direction or in this direction, perpendicular. I mean, like if I say that the wave is moving in this direction C, then the magnetic field would be either in dot direction or in cross direction to make things perpendicular, right? Okay, so what if the electric field, what if the electron is, it is said that the electron moves parallel along the direction of magnetic field. Okay, if we say that the wave is moving along x-axis, okay, the electric field is along y-axis and the electron moves along z-axis. Okay, in that case the maximum force would be 0 because it is parallel to magnetic field. So these very fine points, okay, people, after seeing this, their mind shuts down. They don't even bother to read what the actual question is asking. They just mostly read. Actually the question is really easy in most of the cases. Okay, so that's what the question is asking. Getting my point? The changed question. Even if the electron is moving in this case, okay, a question was there in which the electron was moving parallel to the motion of wave, the motion of electromagnetic wave. Electric field was like this, magnetic field was like this. It was asked how much would be the net force on the electron. So you can calculate the net force. The net force, maximum force for electric would be EE, and the maximum magnetic force would be EVB, है ना? So you can calculate the net force. Okay, so same question, different variations. Okay, I had a list actually of questions and all of them had almost the same thing, right? Okay, shall I erase? You guys wanna write? No. Okay, the next topic we will discuss is energy of an EM wave. Okay, now since we know an EM wave has an electric component given by this, okay, okay, I am writing minus kx because a wave is a function of two things, time as well as position, right? You do remember waves from ninth class. The equation of wave was like from sorry 11th class. Equation of wave was like this, right? So for electric component it is like this. For magnetic component it is like this, sine omega t minus kx, right? Okay. The power associated, the energy density associated with this U electric is how much? Half epsilon naught E square. And the energy density associated with magnetic component is half B square upon 2 mu naught. Right? Okay. So total energy density associated with the wave would be what? Half epsilon naught E square and B square by 2 mu naught. Right? And half epsilon naught E naught square sine plus B naught square by 2 mu naught with a common thing sine omega t minus kx square, right? If I calculate average, so you do remember from our discussion earlier that sine square omega t integral 0 to t dt would have an average value of half. Okay, average value of sine square omega t is half. Okay, so if we integrate this over half period, for in that case x would behave like a constant. We are integrating it for time, so x would behave like a constant and the value would become half, average over a time period. Okay, so this would be 1 by 4 and b naught square by 4 mu naught. Okay, this is the average energy. Now let's see, we do know that actually E naught is Cb naught. Okay, so the electric energy in the average electric energy in a wave would be how much? 1 by 4 epsilon naught c square v naught square. And for c we know that c is actually 1 by under root mu naught epsilon naught, right? So replacing 1 by 4 epsilon naught 1 by mu naught epsilon naught v naught square. Okay, this cancels and we get the original value. Okay, so electric energy density and magnetic energy density are equal. I started with electric energy density and I got magnetic energy density in the end. Okay, so since both of them are equal, UE is equal to UM, I can write that average energy is in purely electric form this, okay, in purely magnetic form this. Okay, right? So this is the last topic we had to discuss in this topic, in this chapter, and I won't be discussing the spectrum. Okay, you need to study that on your own. Okay, you have notes, that's totally theoretical. In the third question, can you find the energy associated with the average energy associated with this wave? In the third question, in the question where we had E as 600 V volt per meter sine of omega t minus kx. Okay, we just did it, we just solved it, we solved it for the maximum force. Okay, you need to tell me how much would be the average energy associated with it. Okay, average energy density, right? Is it that difficult? Half epsilon naught E square, that's E naught square, that's it. Okay, I'm leaving this as an exercise, not discussing it. Not that difficult. Shall I erase it? Okay. Hmm? Yeah. For the average value, for the average value, we found that it's the maximum value of electric field needed. Okay. Purely electric होती तो ये 1/4 रहता है ना, and considering the electric field to be maximum for that, लेकिन it is purely plus purely electric plus purely magnetic, combination of both, so both would contribute same amount, 1/4 thing, so half of this with E as the maximum value. Now a question, a verbal question actually. What is the frequency? The frequency with which energy density varies. Okay, omega 2 omega by 2 4 omega. A verbal question actually. You need not solve it. We had discussed it while we were studying AC. You know it. You must have studied it in 11th as well. Okay. Let's see. Online, anyone? अभी नहीं आया. Shall I tell the answer? हाँ? कोई तो बताओ. 2 omega, obviously. No big deal. The energy varies. Energy is half mu. No, sorry. Epsilon naught E square. Okay. Okay, since electric and magnetic field are coupled very closely, they have same phase, they reach their maximum values at the same time and so on. Okay, same frequency, everything. So the energy, the variation of energy would be same for electric as well as magnetic cases. Okay, so this would be half epsilon naught E naught square sine square omega t minus kx. Now you can express this thing as 1 minus cos 2 omega t minus kx with a bracket, okay, by 2, right? Now this thing would have what? A period half and a frequency double, 2 omega. You see the factor 2 omega? Okay, this thing would have a period of frequency of double the original wave. Okay, and if I draw the variation, it would be like this. You do remember we discussed it. The lobes would be only on the positive side. Okay, UE as well as UB. In both the cases, the size of lobes would be same, exactly copybook. Okay, no difference. Shall I erase it? So with this we have finished the topic. Okay, EM waves, and we still have time remaining. So I'll discuss just 1 or 2 questions of time varying magnetic field with you, and then we'll start with self inductance. Okay, because why I'm discussing it is because self inductance and mutual inductance, they come in picture when current or magnetic field is varying with time. Okay, so in the background it's a time varying magnetic field scenario. So a quick recap. You guys do remember that in a cylindrical region, in a cylindrical region of radius A, if I place radius, let's say A. So if B is the magnetic field, the flux through it would be square and phi B by dt. I'm taking phi. The direction of magnetic field, the direction of the EMF would be, the current actually induced in the EMF in the loop would be like this. So if B is increasing, let us say it is increasing in inward direction, so the induced current will try to slow down the increase, okay, the rate of increase. So it will try to produce a field in the outward direction to nullify the change, okay. So outward field will be produced an anti-clockwise current, okay. Okay, so in this scenario, this induced, this is called a distributed EMF. It is not induced in a small portion, it is distributed everywhere. So it drives a current in this direction. We can use it in this form, as if there are many small batteries arranged in same order, connected in same order, all of them having a total EMF of this, okay. Okay, so if we consider potential difference in a round trip, if we consider potential difference in a round trip, it would be like this, okay, round trip, which is equal to E. And you guys do remember that E is constant everywhere in magnitude because of the symmetry, okay. And E and dl would have same direction as well, because dl we take in the direction of current. So E and dl would have same direction. We would have E dl cos 0, right. E we can bring out because the magnitude is constant, okay. And the integral for dl for over the closed loop would be 2 pi r, 2 pi a, actually the radius is a, is equal to pi a square dB by dt. Induced EMF would be a by 2 dB by dt, right. You do remember this, okay. What if I have smaller region and a loop of bigger size, r radius and a? This is situation when a is less than r, okay. In this case, only this much portion would have changing flux, only this much area would have changing flux. So flux would be pi r square b, instead of pi a square it would be pi r square b, okay. Rest of the steps remain same. I'll focus on the second last step only. E into 2 pi a would be equal to pi r square dB by dt, and E would be r square by 2a dB by dt, okay. So the electric field as a function of distance from center would be like this. It will increase linearly. R is equal to, sorry, A used, A is equal to R, and then it decreases, okay. Okay, rectangular hyperbola, okay. You do remember all this? The thing that I guess you won't be knowing, or maybe you would be knowing, is the charge flown. Do you remember the charge flown? Do you know? In this scenario, let's say magnetic field changes from V1 to V2, okay. So in that duration, how much charge would flow through the loop? That's what I wanted to ask. Do you know? नहीं पता, या पढ़ा है या मतलब पढ़ा ही नहीं है? This much is clear, right? I actually ran through it because this is a recap. Okay, so I'm erasing it. Shall I? Okay. In this case, charge flown through a coil in time varying magnetic field. Okay, time varying magnetic field, short form I'm using directly. We do remember this, that in this kind of scenario, in a cylindrical region, if a loop is placed, okay, in this kind of scenario, the induced EMF was what? Area into dB by dt. Okay, let's use dB by dt itself. Okay, I'm taking a mod actually, the positive value. Okay, because current we generally find using Lenz's law, right? So that if I is the current flowing and R is the resistance of loop, if I is the current flowing and R is the resistance of loop, so V is equal to IR using Ohm's law. So IR would be this d phi B by dt, and we know I is dq by dt, 1 by R dB d phi B by dt. Okay, integrating both sides. Okay, what we get, the charge flown would be delta q is 1 by R delta phi B. I'm using a mod here as well again. Okay, okay, shall I put the limits here? Do you need limits here? Actually, I'm assuming that the charge flown for this time duration is delta q. Okay, delta is to indicate that actually the transition. Okay, it's not a static charge, it's moving charge. And flux changes, let's say phi 1 to phi 2. The limits would be like that. Okay, so the charge flown would be like this. हो तो गया, ठीक है, it's done. Okay, and what if the charge is unable to flow, which by which I mean, what if the ring is non-conducting? If it is non-conducting, okay, the charge, it cannot flow. What would happen is the ring will start rotating. We'll take an example of this as well. Okay, so this I have taught. Let's discuss some questions. Sheet 1 का question देखिए. The first one, the circular coil shown has radius A and resistance capital R and is placed in a uniform magnetic field. Okay, if the coil is rotated about its diametrical axis by 180 degree, find the amount of charge flown through the coil. Okay, okay, in this case the field is uniform but the coil has been rotated, so you have to find the amount of charge flown, and the answer won't be 0. Okay, double ho jayega actually. The question is really easy. Okay, the charge flown is actually 1 by R delta phi B. If I take final flux as pi A square B, the initial flux would be minus pi A square by B. If I take final direction as positive, then initial direction would have been negative. Okay, it is the ring is flipped. Okay, so the area vector changes direction through 180 degree. So in this case, the flux would be negative initially. We can take initial value as negative or we can take the final value as negative, it doesn't matter. either one of them would be negative, either one of them would be positive. Okay, so this thing would be 2 pi a square b. Since we are putting a mod, actually it doesn't matter whether you place a negative sign over the first value or the second value, but what matters is that you understand that initially the area vector was in the dot direction. After flipping it, the area vector becomes in cross direction. Okay, the magnetic field remains same. So in our scenario, if we take it as in outward direction, the initial would be negative and the final would be positive. Okay, initial would be negative, final would be positive. Is it okay? Okay. What about the second one? In this case, the ring is non-conducting. We'll discuss this one surely, because it's a nice question. Okay, shall I read out? I'll read out. A thin non-conducting ring of radius m and of mass m and radius a and uniformly distributed charge q. You know, the charge is uniformly distributed. Is placed inside a solenoid with magnetic field B is equal to kT. Find the angular speed of the ring after time t. Okay, find the angular speed after time t. I'll erase this one. Okay, that's the scenario. Charge q, mass m, and then magnetic field is also there. I had earlier explained that if charge is unable to move inside the ring, inside the loop, it will take the loop along with it. Okay, it will make the loop rotate so that it constitutes a current now. So you need to find how much would be the angular speed. Okay, I'll give you 2 minutes. Third one will take you have to take as a homework. Actually, the third problem, this one. And people here, please, third one likh lena. Please write it down. It's a nice question. Okay, we'll discuss the second one and we'll move forward to the other topic, self-inductance. Self-inductance and mutual inductance, they are theoretical topics, not much can be done in calculations. आया नहीं हुआ? Online people, anyone? कुछ कह रहा है कोई? Someone is saying something. Video and audio quality good. Okay. I'll do it now. Don't worry. So you do remember that actually the electric field acting on this loop would be how much? A by 2 dB by dt. We just discussed it, that for a loop of size smaller than the size of magnetic field region, we have this. Okay, this would act in a direction like this. Okay, if we consider a small portion dq, the force acting on this portion dq, on this charge dq, would be how much? E dq. Okay, the force acting on this portion would be E dq. If E is the electric field, dq is the charge. है ना. We have another dq here as well. These two form a couple. Okay, force acting on this would be e dq in this direction. These two would form a couple. So there are infinite number of small charges lying diametrically opposite. Okay, who would form a couple and make the ring rotate but not translate. Okay, so if I calculate the torque due to this portion, okay, would be df into a or aedq. Okay, for whole of it the torque would be an integral of all, because for every portion the torque would be in clockwise direction, you can see that. So the clockwise torque would be ae into q, integrating, right. Now this torque would rotate the ring. Okay, and the question says angular speed of ring after time t. hmm? So we know that torque would be a q, e is a by 2 dB by dt, a q a square q dB by dt. B was kt, so dB by dt is k. Okay, by 2. Okay, torque is this, and you know the torque is I alpha. If the ring started from rest, then you can say that omega is how much? Alpha t. You do remember na, omega is equal to omega naught plus alpha t, the first equation of motion for rotational motion. Okay, so if it started from rest, which is quite easily apparent. Okay, so alpha we can calculate from here. Okay, or what we can do is we can directly substitute omega by 2 in place of alpha. So I alpha is a square q k by 2. In place of alpha, I am replacing omega by t. So omega would be how much? A square q k by 2. I is the moment of inertia. Do you remember? Tau was equal to I alpha, where I was moment of inertia. For a ring, the moment of inertia is mr square, right? So it is m a square. A square cancels. It would be k q k by 2 omega. Okay, like this it's going. Huh? अच्छा m I missed, sorry. ठीक है. Okay, the third problem, इसको थोड़ा scroll कर दीजिए आप. The third problem is an example, is a homework for you. क्या कुछ? Shall I get the side? And one more thing I would like to add is, if instead of this ring a charge was kept here q, what would have happened? The charge would have experienced a force QE, but QE would have changed its direction. The charge would have rotated, है ना? Circular motion होता, same approach would have been used. Okay, in that case as well. So same type of scenario, you know. अभी तो मैंने इसको मैग्नेटिक फील्ड रीजन दिखाया है. देयर वाज अ क्वेश्चन जिसमें एक सोलेनॉइड था, उसके अंदर चार्ज रखा था फ्रॉम सम डिस्टेंस. मतलब इट इज लाइक दिस, इट इज अ सोलेनॉइड एंड सेंटर से कुछ डिस्टेंस पे एक चार्ज रखा था, ए डिस्टेंस पे, एंड देन अ टाइम वेरिंग करंट वाज फास्ट, due to which a time varying magnetic field was produced, and same kind of approach was to be applied in that case as well. ओमेगा पूछा गया था, same approach होती. Okay, okay, even for a charge, even for a particle of mass m, the moment of inertia would have been mr square, you know it. So same approach होती. You can write it actually that इस केस में रिंग की जगह हम चार्ज भी रखते हैं. In that case also the approach would have been the same. हो गया? Shall I at least erase the diagram? है ना? Diagram तो erase कर दूं? Self induction. Okay. Now see, let's say we have a coil having some turns. Okay. We have a coil having some turns. Okay. Let's say n number of turns. Okay. Now if I allow current I to flow, I'm not concerned about the shape. I'm just doing a general discussion. ठीक है? इस कुछ coil type की shape है. Okay. It may be a square coil or rectangular coil. We discuss the energy conservation in Lenz's law. I have a problem on this. Okay. अच्छा अब कैसे होगा फिर? Someone is उधर भी कुछ हो रहा है. Some user is saying something. सबसे ऊपर I think question नहीं क्या है? Sir please explain again the hemicircle one. अरे hemicircle तो बहुत पहले. अच्छा तो ऊपर वाला. Explain question number 2 once again. Someone is asking that I should explain the question number 2 once again. Okay. And I guess that won't leave us any time with self inductance. See, in the question, in second question, this was like the arrangement. Okay. The ring was non-conducting. Okay. Charge flow नहीं हो सकता था. A was the radius. But because of time varying magnetic field, electric field तो यहाँ generate होगी. It would be generated in any case. Okay, whether there is a ring or not, whether the area is empty, even then electric field generate hoti, which is given by this. Okay, so since the ring is not moving, we would calculate the force on a charge dq. This would be the force. Okay, we have another charge dq here. Okay, let us consider a diametrically opposite part. Okay, so this, if this charge has df force in this direction, this charge would have df force in the opposite direction. They would form a couple. Okay, torque produce hoti hai. Now we have so many diametrically opposite parts, each of them having dq charge. Okay, all of them would form a couple, and the total torque would be added, you know, in okay. So all the torques would be added up, and the total torque can be found using integration df into a, where a is the area. Alpha is omega by t, because initially it in the first go itself, because here today I had to complete EM waves in the class itself, today's class itself. We didn't have any other extra class for this. That's why I first completed the EM waves. Okay. So I'll take the doubt. Okay. ये self inductance बाद में लेंगे. Lenz's law and energy conservation. Okay. देखो theoretically what we say, theoretically मैं पहले समझाता हूँ, फिर we'll take it as an example. Okay. What we say that current is induced in a direction. Let us say a magnet is coming closer, north pole. Okay, it is coming closer. So magnetic field lines, they are increasing through the loop. Okay, and the current would be induced in the loop so as to reduce the magnetic field, or in other words, so as to push the magnet away, stop the approach of magnet. Okay, the magnet is coming in, so the loop would try to stop its approach, slow it down, which would be done in this manner. Okay, let us assume that actually this is what the Lenz's law said. Okay, let us assume that Lenz's law is wrong. Okay, which means we say that as the magnet approaches, the loop produces magnetic field in this direction. Okay, the loop produces magnetic field in this direction, which means this pole would become north, this would become south, because magnetic field always comes out of the north pole, and the south pole would attract the magnet's north pole, so the magnet would further accelerate. Okay, okay. So what would happen in this case is the magnet's energy keeps on increasing out of nowhere. No source of energy is applying any work or energy. Okay, is providing any energy, but still the magnet's energy increases, which violates conservation energy. Okay, so and we are keeping the loop fixed here. The loop was not moving at all. The loop has no means of supplying any energy, but still the energy is increasing. So Lenz's law, in this case, that would have been a violation of energy conservation law. So which means that whatever we assumed about Lenz's law is wrong, and actually Lenz's law is correct. Okay, and now I take up with an example. Let's say these are two conducting rails. A resistance is connected. Okay, and a magnetic field region is there. If we pull it with a force F, with a velocity, constant velocity v, okay, what happens is, induced EMF is BLV. Induced EMF is BLV. Okay, due to this induced EMF, a positive, positive and negative ends, do ye aise, they are formed. I am assuming that the rails are resistance free and frictionless and so on. Okay, so the current induced would be BLV by R. Current flowing, sorry, this would be like this, positive से negative की तरफ out through the resistance. Correct था. The current flowing would be like this. Okay, for this current the force acting would be BIL. You do remember, बिल फाड़ते हैं हमेशा. Okay, and by this logic क्या होगा, inward magnetic field current ऊपर, force backward लगती है. So a magnetic force Fm would act in backward direction given by BLV by R into L, यानी B square L square V by R. Okay, okay. So अगर हम देखें the energy taken by the energy, the power due to magnetic force, अगर हम देखें, is how much? Power taken by the magnetic force is how much? Power is FV dot product के साथ. In case of magnetic force, the magnetic force is in a reverse direction, V is in forward direction, so the dot product would be negative. It would be B square L square V square by R. Simple as that, with a negative sign. Okay, so actually magnetic force is taking power from the moving rod. Okay, okay. Let us see how much power is consumed by resistance. It would be I square R, power through resistance. Okay, which would be B square L square V square by R. So what we can implicate from this is that actually, you know, the magnetic force, it takes power from the rod and actually supplies that to the resistance. Okay, okay. And this, from this we can say that actually the energy of the system is conserved. It is changed from mechanical form to electrical form. Okay, and in this discussion we assumed the direction of EMF, the poles according to Lenz's law. We assumed, okay, because as this V increases, the the area increases, the flux through this portion, the loop increases. Okay, so induced EMF would be in a direction so as to reduce the area or pull the rod backward. Okay, induced EMF would be in a way so as to pull the rod backward. So which is correct? We are taking the FM in reverse direction. Okay, so this proves that Lenz's law experimentally, theoretically as well as experimentally, it is correct. Okay. Okay.
Okay, good afternoon, girls. So last time we did indefinite integration, right? So actually some part of it was left. Almost we finished it almost, but just our last sheet was we were about to discuss the last sheet, and then so we'll be discussing that, and after that we'll be seeing some IIT JEE questions which have been asked for the last 20-30 years in from indefinite integration. After that we'll be shifting to the definite integration, which will be totally a different ball game. So in different integration, we are going to have a fresh look about it. So first we'll finish this indefinite part. We'll say hardly take 30 minutes, and then after that we'll switch to the definite integration. So can I have the last sheet? Yeah. Some of the questions we discussed in a very fast manner, right? Last time. So the first question was x to the power. The first part we actually discussed, right? And the second part, I gave you the hint about the second part. What was the substitution needed for the second part? Excellent. So you will get everything in a very linear form. Okay, and what about third? Third is a little tricky. If you see this question, dx upon x minus b, you'll be tempted to solve through partial fraction. But don't you see that this question will take hell lot of time doing? Okay, so whenever you see this type of problem, what I suggest that you see that this is power cube, right? This is power 3, and you see here power 2, right, in the denominator. So I'm going to assume x minus b upon x minus a as t. I'm going to substitute this way. Okay, what is the use? Why did we think of this? I'll easily substitute this part, right? Okay, so I'm going to differentiate it. So I get something like x minus a square. What will be the differentiation of numerator? 1. So finally we will get b minus a upon x minus a square dx, which will be equal to dt, right? So we have taken care of this part. Now, since we know x minus b is equal to t into x minus a, right? So we can say that 1 minus t into x is nothing but b minus at, right? So what will be x? b minus at upon 1 minus t, right? Now we have to substitute x or x minus b. X minus b. So what will be my x minus b? b minus at upon 1 minus t minus b, which will make this expression as b minus at minus b plus bt upon 1 minus. So finally it will turn out to be b minus a t upon 1 minus t, right? So we can get the simpler form. Everybody? So now it's very easy to substitute now. Dx upon x minus a square will be substituted by dt upon b minus a. 1 upon b minus a will be out. And then x minus b will easily be substituted by b minus a cube will be out. This will become t cube, and it will go upon 1 minus t ka cube. So we have got a very simple form now. 1 minus t ka cube upon t ka cube. A polynomial of 3 degree upon a very simple single guy, right? So you can easily solve now. If you would have solved it through partial fraction, we would have got the answer, but it would have taken hell lot of calculation. How? We would have played this type of game like x minus b the cube into x minus a ka square is equal to a upon x minus a plus b upon x minus a square plus c upon x minus b plus d upon. So hell lot of calculations. So it was better to think of this way. Which made me think this way? This part. and this part. The 3 and 2 part made me think this way. If it would have 4, it would have 3, then also I would have thought the same story, right? Now, fourth part is very easy. We can make sine square x as 1 plus cos 2x by 2, and we can make cos to the power 4x as 1 plus cos 2x by 2 ka square, and then we will get something cos cube, and then cos square, and then cos x. You know how to handle cos cube? You know how to handle cos square? How to handle cos cube? Cos 3x. Cos 3 theta is 43. 4 cos cube theta minus 3 cos theta, and sine 3 theta is 34. Okay. Okay, you can keep this in mind, 34 and 43. Now, okay, fifth is a very good question. Can you tell me how to solve fifth question? X square dx upon x sine x plus cos x ka square. You are going to put x sine x plus cos x t. Then what will happen? Any use? Okay, when you, at the moment you said you're going to substitute x sine x plus cos x. So whatever idea is coming, we are not going to deny it. We are going to see if it's right. We are going to go through it. Otherwise, we'll just come back fast. If I differentiate it, what I'll get? X cos x dx is equal to dt, right? What is the numerator there? So how to handle now? I don't see x cos x anywhere. But I can do little manipulation. I can do little manipulation. There's a doubt? Just tell them that will be. Okay. So I have to do some manipulation. I see x square here. I see x sine x plus cos x square down, right? I can put this as x cos x. Then what I have to put? Right. So I got this and I got this. Now who will help us? The product rule. Product rule in reverse. What is that? Integration by parts. So which is going to be my first function, which is difficult to integrate? Which one is difficult to integrate? This one, because we already see that it's very easy now, right? So we are going to integrate this. We are going to treat this as the second part, which can be easily integrated, and the first part, which is difficult to integrate. So we are going to differentiate it. What is the differentiation of x sec x? It will also come to be a nice thing. X into sec x tan x plus what we got? Sec x common. What is this? X sine x plus cos x. It will go out. So it will finally become x. And will become so it will be a very easy game now, right? Whenever if you get a little confused, just take a rough paper, go whatever the intuitions you are getting, go through that. If you're able to find it the right way, it's fine. Otherwise, if you are getting little hodgepodge, you have to come back. You have to think about it, and then you have to see alternative, any alternative you can think. Or in examination, when you have the MCQs, what is the best way? If you get little confused, you know differentiation is easy, right? Okay, now, if you see question number 6, it is also a very interesting question. I see sine x plus cos x above and sine 2x below. When I was in class 11, I was studying this all trigonometric formula. Then I then that sine 2x and cos 2x was very something which actually fascinated me. Like if you see 1 plus cos 2x gave me a square term, and 1 minus cos 2x also gave me a square term. 1 plus sine 2x also gave me a square term, and 1 minus sine 2x also gave me a square term. And what was the square root of 1 minus sine 2x? Sin x minus cos x square, right? And I see sin x plus cos x above. So you see, sin x minus cos x will be my substitution now. So I'm going to replace sin 2x by sin x plus cos x square, sin x minus cos x square minus 1 minus sin 2x will be right. I can handle now. Everybody know how this derivation came out? Okay, good. So you can handle this question. 7th, I see log into some very weird thing or irrational function, and then dx. I don't see anything other. So what to do? Which is the best way to deal with this? Obviously, we are left only with by parts. Only by parts I can think about it. Otherwise, I'm not able to think anything. But when I see log 1 under root 1 minus x plus 1, I am not initially. If you think that okay, can we do some substitution? So we'll think of putting 2 theta, but it will finally turn out to be. You can do it that way also, and it turn out to be a fine. Otherwise, no need to substitution. We can simply do by parts. We can do the substitution as well, right? The under root 1 minus x I can put as sine 2x or cos 2x. Things will be fine, right? We'll go that way. We can go that way also, or we can go other way also. That let's say, okay, I'm going to consider log 1 under root 1 minus x plus as a first function, which is difficult to integrate, and 1 as a. So first I'll see what is the differentiation of this. So I'm going to differentiate log of something will turn out to be, and then chain rule 1 upon 2 into under root minus 1 plus 1 upon. So finally it will turn out to be something. So I'm going to take out half out. So it will be something like under root 1 minus x square under root 1 minus x minus under root 1 plus x. Right? And then I see this thing. Under root 1 minus x minus this, and I see this thing. So if I square this up, I can get the conjugate, right? 1 minus x, right? So what I'll get? Minus 2x. So I can now handle it. 2x यहाँ से आया, x square कहाँ से आएगा? Dx के 1 से. So it will turn out to be finally 2x square, and it will be turn out to be 1 minus x will go off, 1 plus x will go off. So finally xx will go off, it will remain 2, and then 2 into under root 1 minus, and then you see then again a quadratic form. So you can now easily do the substitution. That way also we can do, or we could have done x, putting x as sine theta, sine 2 theta, or x is equal to cos 2 theta. Both have done our answer, right? Go to question number 8. Okay, tell me question number 8. Tell me just the path. We are just going to discuss the paths. 8th question. What is the click here? I see a log thing in the bracket, right? So I'm going to divide it. So what I'll get? Log x square plus 1 upon log x upon x square. That will turn out to be 1 plus 1 by x square. I see under root x square plus 1 as well. So I'm going to borrow one x from here and I'll go. And I can also create 1 plus 1 by x square. So I see 1 plus 1 x square with a root thing. I see 1 plus 1 by x square with a log thing. And I see x cubed in the down thing. So I know how to substitute now. 1 plus 1 by x square will be my t. And then I'll do and things will be fine. Right? So it will be something like root t into log t. Root t into log t dt. You can handle it by parts? Okay. Question number 9. Now tell me question number 9. See, till this page doesn't have any new type. We are just discussing whatever we have already done. How to go for 9th? I see a biquadratic down. I see a symmetric x to the power 4 and constant. I see symmetry in x to the power 4 and 1. I see 1, 1, right? It's a symmetric thing. The middle term is 5x squared, which I don't care whether it is symmetric or not. But what is interesting here is I got a biquadratic with even powers and it is symmetric. So what is clicking here? ऐसा जब हम लोग last time देख रहे थे, when we were doing in the initial starts, when we were seeing a biquadratic down, and we used to see x square plus 1 or x square minus 1, we were like, okay, fine, we got it. How? X plus 1 by x substitution. But I see here 1. So how to play with this? X square plus 1 minus x square minus 1 upon x to the power 4 into 1 plus 5x square. Now I can handle it. Easy to handle? We have already done this part. We have already done this part. Right? Okay. Now question number 10. Under root tan x. What's the substitution you are thinking of? Tan x to be t square, right? Tan x to be t square, then sec square dx. So things will be very easy now. Question number 11. 2 cos x upon 3 plus 4 sine. The same story. I see 4 sine 2x here. But I don't see sine x plus cos x. Or I don't see sine x minus cos x. But there is very symmetrical thing about sine x plus cos x and sine x minus cos x. What is the interesting thing here? I can any day create cos x or sine x out of these two. If I subtract it, I'll get cos x. If I add it, I'll get sine x. So my solution is done. So I'll get something like half I got the numerator 3 plus 4 sine 2x. I can handle this part. I can handle this part. First part में हमें substitution क्या लेना होगा? Sin x minus cos x. And second part में substitution क्या लेना होगा? Sin x plus cos x. Things will be fine, right? Easy question. So whenever you see, if you don't see this thing or you don't see this thing, you don't have to panic. You have to think how I can create it. Like similarly, x plus 1 by x, x minus 1 by x. You don't have to panic. You can any day create constant out of them. You can any day create variables out of them, right? Where were we? 11th. So 12th. Okay, sec x. It doesn't make me feel good. So how to handle sec x? I'll make it 1 upon cos x. It will go up, and 2 sin x cos x will be. So 1 plus sine 2x cos x up. I can handle cos x now, right? Question number 13. I see a 4-degree polynomial upon a 3-degree polynomial. So first I'm going to do the division. So I see x cube minus x square minus 2x, x to the power 4 minus 3x square minus 3x minus 2. Right? X will be my quotient. x4 minus x cube minus 2x squared. Done. Gone. This will turn out to be x cube. It will turn out to be minus 3 minus that will be minus x square minus 3x minus 2 upon what is the denominator? Okay, I can still handle it. So it will be minus 3. This will be minus 2x square x cube minus x square minus 3x minus 2. Now I can handle it with 1. So this is fine. I got it x cube minus x square minus 2x. So it's fine. It's fine. So it will be minus x plus 2. Okay, I got a very linear thing. And below I got so I can handle it. Minus x plus 2 upon x cube minus x square minus 2x. So how to handle it? First, ये तो आराम से हो जाएगा. And then 2 upon x cube minus x square minus 2x. So how to go for it? Okay, we can factorize it. What will be the factorization? X into x square minus x minus 2. These two also will have a root, right? And that is a natural number root. So I can do the partial fraction, right? So I don't have to go for x removal of x. I can simply do the partial fraction with minus x plus 2 is equal to minus x plus 2 upon this is equal to a upon x plus b upon this will be x plus 1, right? So it will be b upon, very easy question, right? Polynomials are very easy to handle. Now 14 is again, it will be a calculation thing, but it will be very easy. 12x upon x minus 1 ka cube upon a quadratic expression. So how we are going to do the partial fraction? Left hand side is equal to a upon x minus 1 plus b upon x minus 1 square. You just have to be a little patient. And you have to multiply and a little patient. That's the only solution here. Now question number 15. I see a cubic term up and a, okay. So how to go for it? I can break my x cube plus 3x as x cube plus x and then 2x plus 2. X cube plus x plus 2 into x plus 1. X square plus 1 square. I think now you can handle it. Right? You'll get x upon a quadratic expression. You'll get 2 upon quadratic expression. Biquadratic. So again, even powers are there. So you can handle how you are going to handle. When even powers is there, you don't have to substitute. You have to break partially fraction by taking x square as y and then break it. Right? So you can handle it. Good. Everybody was with me? Anybody who lost the track? No? Okay. Now I see question number, where were we? 15. 16 I can easily handle. I'm going to break sine 2 theta as 2 sine theta cos theta. My cos theta will go out. And then I'll get everything in sine theta expression. And in below I'll get a quadratic expression. Above I'll get a linear expression. I can handle that. Now 17 part, I see a linear term cubed into under root quadratic. So whenever I am going to see a linear term into root quadratic term, I'm going to substitute my x minus 3 as 1 by t. Things will be fine. Okay. 18. So 17 is done. 17 is fine. 18. 18 is a very interesting question. You just have to play with the expression and you are done. I see x cube plus x square plus x minus 1 upon x square minus under root 2 minus x square dx. So I see x square minus 1 up, I see x square minus 1 down. So एक expression I see dx upon under root 2 minus x square. I can handle that. Then things will, I'm left with x cube plus x. Then again I am going to make it out. See. वो तो समझ में आ गया ना, एक पार्ट जो हमने एलिमिनेट कर दिया है वो समझ में आ गया ना, वो तो यू कैन हैंडल इट. वी वर लेफ्ट विद दिस. सो x square minus 1, I say x cube plus x. Well, how to handle it? Minus x plus 2x. So I can handle this. Right? X square minus. I got a quadratic expression down and a dx form x dx. I can easily substitute the under root 2 minus x square part. What I'm left with now is 2x dx upon x square minus 1 into under root 2 minus x square. How to go for it? Done. Now, question number 19. I think it's 2x square plus 5x plus 9 and x plus 1. Okay, it's a good question. How to go for it? 19, tell me. I see a linear term down. I see a quadratic term with under root part. So first, and I see a quadratic expression up. So I'm going to break my thing 2x square plus 5x plus 9 as a into x plus 1 into what is the differentiation of x square plus x plus 1? 2x plus 1 plus b into x plus 1 plus c. I can handle it now. Right? How to handle it now? A, the moment I got A, the question is very easy. I can find A just by comparing the coefficient of x square. Then the moment I found B, things will be B into dx upon under root quadratic expression. We can handle that. And the last part will be C upon linear into under root quadratic. How to handle that? Putting linear term as 1 by t. Clear? Question number 20. Okay, this whole thing. I saw a quadratic expression in numerator, right? And I saw below a linear term into under root quadratic. So I'm going to take a factor of linear term into the differentiation of x square plus x plus 1. That is 2x plus 1. This is quadratic expression into A plus B into linear term plus C. I can break my quadratic expression in this form. I can find my ABC corresponding ABC. The moment I got my ABC, I have to solve this question. Becomes very easy. This question also becomes little easy. This has become little lengthy, but this is how we have to solve it, right? Now, since nowadays you don't have mains this subjective paper examination, so they don't ask this type of very lengthy type of questions. They ask very normal type of questions. Now 21, February 19. 20 is very easy. How to go for it? I'm just going to multiply and divide by sin x. I'll get sin square x down. So I get a dt part up and a quadratic into quadratic part down. I can handle that. How to handle that? This will be sin x dx upon 1 minus cos square x into 2 cos square x minus 1. So minus laga do, minus bahar kar do. So it will be dt upon 1 minus t square into 2t square minus 1. कैसे करेंगे? A by 1 minus t square plus b by 2t square minus 1 is equal to 1 by t square. Bas, partial fraction. If you are not comfortable with this, just make it y. Make it y. And then find the answer in find the partial fraction in y, and then again substitute in. Yeah, but I don't see anything up. I see up even powers only, right? So it won't give me any use. It will make my question a little more difficult, more lengthier. You can do that way also. T plus 1, 1 plus t into 1 minus t, then see the root part here. Things will be very messy. Okay. Now, whenever you see even powers upon even powers, think of partial fraction, even powers upon even powers, and then don't do the substitution, but just do the breaking of thing by taking u as x square as y, and then breaking everything into y, and then getting back into the even powers. So I can handle 21st as well. How to handle 21st? How to handle 21st? I see sine square x cos x, sine x plus cos x. So it's a little thing. How to go for it? Huh? This cos x is a little disturbing, right? I can bring it down. It will become sine square x 1 plus tan x. Right? Now, means I have to get everything in tan form. So how to handle sine square x? Simple. Divide by cos square x and then multiply by 1 by sec square x dx. So what I'll get? Tan square x. I know what is sec square x. That is 1 plus. Right. Now what to do? Put tan x as t. So t square right. So dx upon 1 plus tan square x is your dt. Very easy, right? Very easy now. Clear? So whenever you are not happy with something like sec, cosec, you will get the hint, you will get the hunch. Now 22nd. I have seen this expression before. What was the expression? I have seen this expression before. And this actually helped me in one substitution. The second question, you remember? What was the substitution we did? A cos square theta plus B sin square theta. Things will be fine for me. Right? We can handle this question 22nd? Or should I show you on the board? Okay, let me show you. So whenever I see this x minus alpha into b minus x under root form, I try to get rid of this by making x as a cos square theta plus b sin square theta. Right? Alpha here. Right? So what will be my dx? Minus 2 alpha sin theta cos theta plus 2 beta sin theta cos theta. So I got very fine term in the dx part. And then x minus a becomes, x minus alpha becomes beta sin square theta minus alpha sin square theta. And when I see beta minus x, I get beta cos square theta minus alpha cos square theta. So this is a perfect square thing. B minus alpha will come out, and then B minus alpha you will get some from the up as well. So things will be very fine now, right? Now 23rd is about talking about reduction formula, which we'll be discussing in definite part as well, the reduction formula. But let's do a little bit of this. If I see In is equal to ln x to the power n dx, what does it mean, In? It means that it's some function. It is some function which is depending on n, right? So In is basically ln x to the power n dx ka integration. You understand? When I say In minus 1, what does it mean? Ln x to the power n minus 1 dx. When I say Im, what does it mean? Ln x to the power m dx. Getting the idea how n is depending on it. Now, if I say I2, this will become log x square dx. If I say I1, this will become log x dx. The simple discrete thing, right? Now, let's say I have to integrate this. So how we are going to handle this? By parts. That is the only way we can handle it. So I'm going to take this thing as the function which cannot be integrated. So ln x to the power n. And what is the integration of dx? X minus x into, what will be the differentiation of n? So I got something like In is equal to x minus n into, that is what we have to prove, right? It's easy. We'll see more of a reduction formula in the second part, indefinite integration. I've stopped it intentionally. Most of the people, they do it in the indefinite part only, but for some purpose, I stopped it. Now 24th, you see, now 24th is very easy to handle, right? How to handle 24th? Under root x minus 1 into x. I'm just going to multiply, I'm just going to square it up. So I'll get x minus 1 and below I'll get under root x minus 1 ka square. And then I can handle it, right? I don't have to go into detail. Now it's 25th, tan x into tan x plus a. I'm just going to simplify this. Tan x into tan x plus tan a upon 1 minus tan x tan a. Finally this 1 plus. So finally it will be 1 minus tan x tan a, and that will be 1 plus tan square x into dx. Very easy to handle, right? 26th, 1 plus x upon x into 1 plus x e to the power x square. I think some of the questions you have already got in the assessment part, right? So you handle it. How to handle this question? Will be your t. Then e to the power x, you have to multiply and divide by e to the power x to get dt. And below you will get t minus 1. It will be fine, right? It was an IIT JEE question. 27th. Many of the questions which we have discussed have already been asked in IIT JEE. The 27th. How to handle? How to handle sec x under root sine 2x plus a plus sine a? Sine c plus sine d. What is sine c plus sine d? 2 into sine c plus d by 2 into cos. So similarly, we'll go sec x dx upon under root 2 into sine x plus a into cos x, right? Now sec x dx sec square x, and then I'm going to put 2 sin x plus a upon cos x. Now it will be what is sin x plus a? Sin x cos a. So it will be tan x, and then the second part will have cos x sin a. That will be out. So I get something in tan form. So I got something right in a linear form, dt upon under root linear expression, right? So that's it. This page is finished. So I'll just have a, we'll not solve the IIT questions. We'll just have a look and we'll just talk about it, and then we'll start our definite part. See, past IIT JEE questions of indefinite integration. So we are just going to talk about it. The first part is I see an integration on the left side, and right side I see ax plus b log something plus c. How to go for it? The basic definition. I'm just going to differentiate both sides. My integration part go off. Left hand side will be the whole expression, the integrand. This expression will remain alone, and right side x will go off. That will become a. I can easily differentiate this plus c, and then I can easily manipulate my a and b and c. C will be any real number. Why? Because integrated and we are getting c as a constant. So c can be any real number. Part B, second question, the value of the integral cos cube x plus cos. I think very easily you can handle it. Cos x बाहर निकल के आएगा, and then things will be fine, right? Question number 3, you can handle it. It will be a lengthy question. 2006 में आया था ये question. It is a little lengthy question, but you will be able to handle it. How? I can divide everything by x. So x, अगर if I put x square under, it will be 2 minus 2 upon x square. ठीक है? So क्या कहते हैं? Do these type of questions. Do all the manipulations. You will be able to handle. Fourth part. You see j minus a. I see a. I see j. There is a little similarity in I and j. I see e to the power 4x plus e to the power 2x plus 1, and I see here e to the power minus 4x plus e to the power minus 2x plus 1. So I can get my numerator as e to the power 3x, and numerator will become same. So the expression will become j minus I, e to the power x minus e to the power 3x. E to the power x, I can take it out. We'll be left with 1 minus e to the power 2x. And I am going to substitute e to the power 2x as t. So this will become 1 plus t square plus t to the power 4 above a quadratic expression. You can easily handle it. Quadratic upon biquadratic, x plus 1 by x form. Right? Second part, fifth question. It was asked on 2012. Sec x plus tan x. What substitution should we do? Sec x plus tan x. And that will be a very nice substitution, because sec x plus tan x will give you sec x tan x plus sec square x. Basically, sec square x, sec x dx will turn out to be dt upon t, and things will be fine, right? Seventh is very easy question. Sixth, seventh, both are very easy question. I don't have to discuss. Eighth question, under root 1 plus sin x by 2. Whenever I see 1 plus sin something, I can make it a square thing. So it will be sin x to the power sin x upon 4 plus cos x upon 4 dx. I can easily handle that. Question number 9 is very easy. Under root 1 minus x to be substituted as t square. Things will be fine. E to the power log x is nothing but x. E to the power log x is nothing but x. So x plus sin x cos x, I can handle it. This question we have already done in the assignment. E to the power x into fx plus f prime x. Question number 12, I am going to take x out of it. So it will be 1 plus 1 upon x to the power 4, and below I will get x cube, 1 upon x cube. So 1 plus 1 by x to the power 4 will be my substitution. Right? We have done already this question. This question is also very easy. You remember inverse trigo? What is sine inverse root x plus? It will be a constant thing, pi by 2. And I can replace this by sine inverse x minus pi by 2 minus sine. That will be finally 2 sine inverse x minus pi by 2, and I can handle that. Right? Next page. See, IIT questions, they're not very difficult questions. So root cos 2x upon sin x last time we discussed, right? I got a better substitution as well. When I went back home, I found a better. Cos 2x by sin x, I can write that as under root cot square x minus 1. Right? I can write the expression this as this. I'm going to make cot x as sec t. I can substitution. Cot x as sec t. So cot x will become sec square t minus 1, and here it will be minus cosec square x dx is equal to sec t tan t dt. This will come down and turn out to be 1 plus cot square x, and cot x 1 plus. Things will be very easy now, right? Question number 6, root tan x plus root cot x. How to go for it? 16. I can write root sin x upon root cos x plus root cos x upon root sin x. Things will be easy now, right? Sin 2x अंदर आ जाएगा root के साथ और ऊपर सब खत्म हो जाएगा. It will be sin x plus cos x, and you know how to handle that. These are the questions which have been asked in IIT. See, 17th question, even that subjective time era. I'm talking about subjective era when the question used to be a little difficult. So indefinite integration have always been an easier part. 17th, you see, I see x to the power 1 by 3. I see 4 x. I think there is some misprint. It has to be x. I think I just typo it wrong. So x to the power 1 by 3 plus x to the power 1 by 4. How to handle this? No, substitution. I'll just do the substitution. What substitution? X is equal to t to the power 6, t to the power 12. Similarly, I see 1 by 3, I see 1 by 2, I see 1 by 6. So I'm going to substitute x is equal to t to the power 6. Things will be fine. Right? This question is very easy. Cos 2 theta, log cos theta plus sin theta, cos theta minus sin theta. If you differentiate it, you will get something cos 2 theta. So it can easily by part it. This one we have already discussed. The substitution needed is x is equal to sin square theta. So you will get something fine. Everything will be fine. This is 21st is a partial fraction question. Down. 21st is a partial fraction question. Right? 23rd is a good question without 23rd. For any natural m, the click in this question lies somewhere here and somewhere here and somewhere here. Everything is actually so compelling. I see 1 upon m. Anyway, I have to substitute this thing. है ना? And there I see 1 by m, and I want, if I see 2m, but I can make यहाँ 3m minus 1 होना चाहिए था, 2m minus 1 होना चाहिए था, m minus 1 होना चाहिए था तो कर लेते हैं. I'm going to divide by x, so multiply by x. When x will go inside, this will be x to the power m, so the thing will become x to the power 3m minus 1 plus x to the power 2m minus 1 plus x to the power m minus 1 into 2x 3m plus 3x 2m 6x m by 1 by m dx. अब handle हो जाएगा. Now it's very easy to handle. How? I'm going to substitute this as t. So it will be 6x to the power 3m minus 1, 6x to the power 2m minus 1, 6. So I need 6. Very easy question. No, actually examination, the temperament is different. So you will be little nervous. Key. I haven't seen this type. Okay. Now the last question. 24th was I think the most easiest question. It came when I was appearing in IIT JEE in 2007. So it was the easiest question, I think. I don't want to discuss this question. It's very easy. Can you go come down? See, the 21st question is it's an indefinite integration. I see statement 1. It says that fx satisfy fx plus y pi is equal to fx. In step 2, sine square x. Fx is an indefinite integration of sine square x. Means f capital Fx is sine square x dx. Obviously, that won't be a periodic function. So statement 1 is false. And first 3 options is itself is saying statement 1 is true. I don't have to think anything about ABC reading out, because statement 1 itself is a false statement. So statement 4 is the right answer. The option 4. That was very easy question when asked in 2007. Okay. So now we'll be shifting to the definite integration part, right? So now it's very important time. We have to shift our attention from the indefinite integration to a definite integration, which is totally a different ball game. Because in indefinite integration, we were talking about a class of functions, right? We were talking about a class of functions. But in definite integration, we are going to talk. Definite integration is nothing but a numerical quantity. It's a numerical quantity. I'm sure you have been exposed to definite integration right from class 11, but I'm also very sure that you do not understand actually what it means. Okay, so first we are going to take a very fresh and a good look at this, and then we are going to define it accordingly. So if I have to define definite integration in one line, I would say that a larger and larger numbers of smaller and smaller local values, larger and larger numbers of smaller and smaller local values, and I'm summing it up to get a global sum. That is the whole game of definite integration, which will be dealing totally with a numerical quantity, right? So it's totally a different game. So don't think that indefinite has something. Yes, of course, there will be some link, and we'll see how that links is interconnected, right? Now, first thing which I wanted to talk about, first we are going to consider integration as a machine which calculates area, a machine which calculates the signed area. You know what is signed area? Of course, when I say signed area, either it has to be plus or minus. When we were studying coordinate geometry, straight lines, we were talking about signed distance, plus or minus. If you go right, plus. If you go left, minus. Similarly, in area also, we are going to define convention as a positive area and as a negative area. So let's say I have this function. So we have defined a definite integration. We'll be going symbolically, we are going to write this way, that okay, fx is a function, and then it's a curve. The area between the curve and the horizontal line will be, which we have to calculate. So we are going to consider this as plus and this as minus. So I get some area here, something, and I get something here. So the answer will be this minus this. Okay, so it will be a machine which will be calculating the area. Okay, let's say I have to find 0 to 3 x dx. So I'm going to ask my machine to calculate. So I can see geometrically also I can find the answer. I'll say, okay, so the answer will be the area of this triangle, and I can say, okay, this is 3, this is 3, so answer would be 9 by 2. I got it. This answer is 9 by 2, right? But I don't know how, but using the simple geometry which I know, I can calculate that 0 to 3 x dx is 9 by 2. Similarly, let's say I have to find -1 to 3 x dx. I'll ask my machine to calculate, and I can check out how to solve this. This will be something like ये होगा -1 to 3. I know this area. This will be 0. This will area. This area, and this is alone. So I'm not going to find that, right? So my answer would be finally this is 1, this is 1, this 1, this 1. Height is 1. So it is -1. It is +1, and it is +2. Okay. So what will be the answer? This will be cancelled. This will be cancelled. I'm left with 2. So we are basically using a simple geometry. You must be thinking, ki, sir, but for a difficult integration, we were using something else. But actually, you were using the geometrical properties only. You were actually trying to find the area only. But the question is, what does area mean? What do you mean by area? What do you mean by area? When I talk about area, I remember my class 6 days, area of rectangle, right? That was my area. That area of rectangle was AB. And then I learned area of right triangle is half AB, right? When someone told me you have a rectangle of 1 into 2, can you make a square out of it? Yes, I can make the same. Both areas are same. If I strip it up, I can paste it here. It will be totally occupied. If I make it 1, 3, √3, √3, I can paste it, right? But the moment I heard about the area of unit circle, what was the area of unit circle? What is the area of unit circle? Pi. So the moment I saw pi, and then I drew a rectangle, can I strip it and paste it here, and will that be equal? Here, whenever I say my area of circle is pi, I'm secretly using the concept of limits. You must be thinking that in high school days we were never talking about limits, though we were talking about geometrical. But when we used to say that area of circle is pi, we used to say that secretly we were using the concept of limits, which we have studied now. Let's see how. This is my unit circle. I'm going to so this will be my so if I chop it up into my various rectangles, right? My area will be getting closer to pi, and I can make it as close as I want. The moment you hear as close as I want, what do you think of it? It's nothing. We are talking about limits. The finer I'm going to make it, I'm getting closer to pi. How closer? As close as I want. How as close as I want? As thinner as I want. Jitna bhi main thin karunga, how the finer it is, the closer it will be. So it's totally depending on me. So area somewhere has to do something with the limit thing. I can get as close as I want. So regarding as far as polygons were considered, we were able to find the area in exact form, right? But when we talk about the curve, we have to think in a limit term. Secretly, we are speaking in a limit term. We are getting my answer as close as I want, right? Now see, This is my y is equal to x square. Right? Okay. Let's say I have to integrate x square dx from 0 to 3. Right? So what I did, I try to break okay. If I make this thing finer and finer, finer and finer, we are getting closer to my area. And if I'm going to make it finer and finer, finer and finer, I'm going to go. But this is underestimating, and this is overestimating, right? You see, this is underestimating, and this is overestimating. Here we are approaching from left. Here we are approaching from right. You understand the idea, right? So there was this thing. Now we are going to make this thing. We are going to create expression out of it. Okay, how we are going to. So finer and finer means I'm going to break my 0 to 3 part into an infinitely very small size, right? A very small size. So what I'm going to do. Can I rub this? What I'm going to do is let's say 0 to 1. I'm going to break my this thing into a finer into n parts. So I'm going to call this point as x0, x1, x2, xn minus 1, xn. This is how I'm going to break it. Now I'll connect everything. Now the idea is I have to find the area of this rectangles. So I must choose a sample point. I must choose a sample point. I have the breadth. I have the breadth, but I don't have the length now. And length is depending on the curve part. So I must choose a sample point. The sample point can be x0, x1, x2 till xn minus 1. That was underestimating. Or my sample point could be x1, x2 till xn. That was overestimating. Right? So if both way we are arriving limitizing and we are arriving to the right answer. So we can say first we are going to do the left hand side. So I'm going to say left Riemann sum. You know the mathematician Riemann? No? So it is called a left Riemann sum. So I'm going to write this as, you understand this sigma? You must have studied this in sequence series topic, right? Now I'm going to see this sigma. I'm going to take my sample point from 0. So my I will start from 0 and it will end till n minus 1. I'm going to choose sample point fx I. This is my sample point fx I. And what is the width? One by n. This is, or if I'm going to take a limit out of it, means I'm going to make my n as finite thing, then I'll get an approximate area. So I can say this area will be equal to, so area ka symbol hai 0 to 1 x square dx will be approximately equal to sigma I starting from 0 to n minus 1. What is fxi? So this will be 1 by n. This will be 2 by n. This will be n minus 1 by n, and it will start from 0 by n. Okay, so I can say I by n ka square, right, into 1 by n, limit n approaching infinity. You know the operations of sigma? So this is left hand Riemann. This is left hand Riemann, and I can find the answer. What will be the answer? I can take out n square out, I can take out n out. So limit n approaching infinity 1 by n cube sigma I square, I approaching from 0 to, so I can get my answer. What is the summation of square? N into plus 1, n into n plus 1 into 2n plus 1 by 6. And what is sigma n cube? N into n plus 1 by 2 ka whole square. And what is sigma n4? No. See, whatever the operations we learned about this curve thing, the same thing goes for sigma as well. So I'm not going to multiply this. So I'll just give you a challenge that how to find sigma n to the power 4. How to find sigma n to the power 4? Exactly the way we found sigma n square and sigma n cube. My question is how we found this sigma n square. The telescopic series. You understand telescopic series? What was telescopic series? In sequence series, if you see, I can write, let's say I have to find sigma n. So I can write n plus 1 ka square minus n square. What will be the left hand side? N 2n plus 1, right? N square hai na? 2n plus 1. Now I can sigma both side. What will be the sum of this series? It is a telescopic series. The bigger term will remain. It will keep on cutting out. Na? You don't remember telescopic series. So n plus 1 square minus n square. So finally it will turn out to be n plus 1 ka square minus 1 is equal to 2 sigma n plus n. You got it? You got the answer. Similarly, for n square, and similarly for n cube, when you get back home, try this. Okay, and for n to the power 4, just for fun, they do not ask. Okay, you'll be able to handle n to the power 4 as well, right? And you can check your answer by going to 3 terms by induction. So we understood left hand Riemann, right? We understood? And when we have to take right hand Riemann, we'll start my calculation from I is equal to 1 to n I by n square into 1 by n limit n approaching infinity. What will be the answer? 1 by n cube sigma I square limit n approaching infinity. Finally, limit n approaching infinity n into n plus 1 into 2n plus 1 by 6 n cube. 1 by 6 out. 1 into 1 plus 1 by n into 2 plus 1 by n. Limit n approaching infinity. This will be 1. This will be 2. Answer would be 1 by 3. Right? Now let's say, so we have found that 0 to 1 x square dx is 1 by 3. Right? We found 0 to 1 x square dx is 1 by 3. And when I say 0 to 1, 3x square dx, that will be 1. Now my question is, let's say this is my graph of 3x square. This is the area. What is the length of this area? What is the area of this area? 1. Can I say this is equal to? Can I say both are equal? Can I say one square little kinged out or one square little aged out? Kinged in, aged out, right? So when I say the area of 1, I actually mean this. I can get as close to 1 as I want. How much close? As much as I want. See the limiting factor, right? So you saw the left hand remain, you saw the right hand remain. So what was the key point? You have to break the x thing, the limit thing, into n parts. Okay, the width will be b minus a upon n. The width will be b minus a upon n. Your sample point will mostly take the right hand side. So the sample point will start with 1. So it will be b minus the first part 1 by n, then 2 by n, then 3 by n, then 4 by n. Similarly, okay. So we are now going to just define it. Our definite integration as my definite integration will be integrable if my fx is continuous in AB. And when I say it will be integrable, it means I can easily find the area of the curve from A to B. A to B fx dx. Remember, A to B, it has to be continuous. It has to be continuous. If there is a break, we won't be able to calculate it, right? Is equal to limit n approaching infinity sigma. Okay, I'm going to take f of I by n a plus I by n. Getting the idea? This is my definition of. But now the question is, you must be thinking that it's a very ugly way of finding the definite integration part, right? You remember a long time ago when you were doing differential calculus, you started differentiating using the concept of first principle, and that was very irritating. And with later on, you developed this chain of formulas, right? And then you were little comfortable. The same way we are going to create something and things will be very fine, right? So initially it looks little weird, but don't worry, we'll be able to develop it, how to go for it. So till here, no issue. Now, how that magical thing came? That magical thing that A to B fx dx is f capital B minus f capital A. It's a magic thing, or how it turned out to be. So we are going to see how, right? Till here, everything's fine. Today we'll just do the theoretical part, and then tomorrow we'll see everything. Now, before I go into that, please go to the next sheet. I'll just tell you how to solve the first sheet. This whole first sheet is the questions of limits of a sum. Okay. The first part is a very tiring part. We have to do using the Riemann part. Riemann right-hand limit. You can break everything into fi by n, and 0 a to b, it can easily be broken b minus a by n. Okay. So these three, that sigma n cube, that will turn out to be sigma n cube, and then 1 upon n to the power 4, and then you will be limiting it. Again, here is also, it will be a little difficult, but you will be able to tackle that out. And you can check your answer by fb minus ff thing, right? But don't worry, in examination, they are not going to ask. Maybe in board examination they can ask. Okay. Now, second part, I'll just tell you the working rule. We have already understood the definition. I'll just tell you the working rule. I'm just going to discuss first question. The first question I can say 1 upon n plus r goes from 1 to n. Limit, I'm not writing limit n approaching infinity, it's understood, right? Okay, it's going from 2 till 2n, so r is going till n, right? Now, I'm just showing you the working rule. It's understood that limit n is approaching infinity. So 1 by 1 plus r by n into 1 by n. I can write this way. Okay. Now the working rule is we can replace this sigma by this sigma. We can replace this sigma by this sigma. We can replace 1 by n by dx. And we can replace this nothing but f of r by n. So I can say 1 upon 1 plus x. And I'm going to say if r is approaching 1, n is approaching infinity, it means 1 upon n. Okay, understood? The working rule, you got it? You got the working rule? ये यहाँ से यहाँ कैसे आया? Got it or not got it? Got it, na? So the working rule is punch rule that sigma to be replaced by sigma, 1 by n to be replaced by dx, limits to be taken care accordingly. If I say 5n, so it will be clear. It means I'm breaking 0 to 5 thing. 5 by 5n. It's understood. Clear? 5 minus 0 is 5. 5 by 5n. है ना? Clear? So things you are going to sort out this way. But the question is how we are getting the FB minus FA part. So now I'm going to into that. See, I'm going to define an accumulation function. I'm going to first define an accumulation function. Accumulation function is nothing but it's a function of x which tells me a to x ft dt. What is the definition of accumulation function? It's going to find the area between x is equal to a to t is equal to a to t is equal to x. The variable here is t. T is equal to a to t is equal to x. So I'm going to say this, that this is, let's say this is my function ft. And I'm going to say this is my x, t is equal to a, and this is going to be t is equal to x. This is my y, this is my t. So the plane is yt plane. The plane is yt plane. I see ft here. Okay. This is going to find this area. Right. This is going to find this area. If I change x to here, my area will increase. So I know with increase in x, ax increases provided ft is positive. ft positive है, अगर ft positive है तो ax increase कर रहा है. ax increase कर रहा है मतलब a prime x is positive. When I say a prime x is positive, I say ft is also positive. So I see a link, a relation between a prime x and ft. I see a link, right? Similarly, if my function would have been this way, below x is equal to a, t is equal to a, so t is equal to x, right? ये मेरा area था. If I would have increased, it would have decreased further. It would have decreased. So I see with when ft is negative, my ax decreases with x, which means a prime x is negative. So I see a relation here again. So this is giving me a hint. That it is giving me a little hint about it. Okay, the moment I see, this is the story. Clear? Now, let's say I'm going to define a function fx as a to x fx dx, ft dt. This is very important. You see the how it is deriving. Why it is important? Because later on things will be जो normally books में लिखे होते हैं, mug it, remember it. So I'm not going to do that way, right? So you see fx is this. So I can say my fb is a to b ft dt, right? And I can say my fa is a to a ft dt, which is equal to 0. Okay, till here any issue? No. Let's say I'm thinking of function gx whose differentiation is fx. Right? We can see this. G prime x is equal to fx is equal to f prime x. It will be capital fx minus capital. You're getting the idea? Getting this idea or not getting this idea? Not getting this idea. If I say fx f prime x, what it means? It means limit h approaching 0, 0 to x plus h ft dt minus a to x ft dt upon h. This was the basic differentiation problem. Now a to x plus h minus a to x. So finally, if I subtract it, it will turn out to be x to x plus h. So finally, it tells me that my f prime x is going to be fx. Clear? So I can say g prime x is small fx is equal to capital F prime x, right? Now, which means I can say my fx is equal to g of x plus c. Can I say this? So I can say my fb will be equal to g, my fa will be equal to ga plus c. What is fa? What is c? So I can say my fx is, so I can say my fx is gx minus ga. So I can say my fb is so finally we got it. We got it how that magical thing is coming up from A to B, right? How it started? It started, we considered an accumulation function, a function which was calculating my area in YT plane when T is varying from A to X. We understood the relation that, okay, accumulation function is increasing when positive, decreasing when negative. So we got the correlation. Okay, fine. We have something related to the A prime X and Fx. And then we defined, okay, Fx is this. So Fb is this. Fb is this. It means G prime X is equal to Fx is equal to capital F prime X, which means capital Fx will be equal to Gx plus C, which now I know Fa is my 0. So I just put Fa 0. So Ga plus C. This is how we used to find the constant. C is minus Ga. So I just put Fx is equal to Gx minus Ga. And what is the Fb? Clear? So now it's easy now. Now we can actually do the problems. So we have 20 minutes. So let's solve the questions now. Okay, one important thing which I wanted to talk about. If I say Fx is A to X ft dt, what will be my F prime X? Fx. Clear? My question is, if my Fx is A x cube ft dt, what will be my F prime X? 3 क्या होगा अंदर? How? कैसे? See, we are not going to talk anything which we do not know. Okay, I read somewhere. I have already understood this. So I'm going to define, I'm not going to see fx, I'm going to see define a function gx as a to x ft dt, right? Now I'm going to use the concept of composite function. I'm going to say my fx is g of x cube, which is equal to a into see why you got confused, right? Because you were not thinking how the composite function is being applied. So now if I say f prime x, I can say g prime x cube into 3x square. I got the answer. And what is g prime x cube? G prime x is fx. Clear? My question now, if fx is ux vx ft dt, what will be f prime x? What will be f prime x? Again, think of composite. So I'm going to say 0 to vx ft dt minus 0 to ux ft dt, right? Now I can differentiate it. It will be f vx v prime x minus f ux u prime x. See, now it's making sense, right? Now you can make sense. You don't have to remember. Later on, I will also ask you to differentiate something like f of xt equal to ux vx f xt dt. Okay, we'll also see how to handle these type of questions, right? But later on, when we'll be little friendly with all the properties and all. Okay, so you know how things are working? You know how Leibniz rule came out to be? How now whenever anybody asks you how this fb minus fa, you will be able to handle it. The concept is accumulation function, right? So I think we'll just do the limits of some questions, and then tomorrow we'll discuss the properties and all. Okay. See, I have already discussed first part and second part. First part and second part we have already discussed. What about third part? I'm going to write sigma. I'm going to see my general term. My general term says under root n plus r by n root n. This is my general term. And my r goes from 1 to where? N. Limit approaching infinity. Keep it in mind, right? So I can say r is equal to 1 n under root 1 plus r by n. You know the working rule? This has to be replaced by this. Clear? It's very easy questions. You see, first ABC was difficult, but second everything is easy now. The idea is you must understand the working rule. Now see D part. Okay, first term is little confusing, but the second term and third term tells me what is the first term. The first term is nothing but n square by n cube. So it means it is a left hand remainder. See, r is going from 0. I'm going to first write my general term. It will be n square by n plus r. R goes from 0 to the last term is 8n. So if I put n square plus n plus n minus 1. Wait, what is the last term? 8n, right? So n square. Okay, n plus n ka cube. So it's going from 0 to plus 1. Yes, it starts from 0 term. Start from 0 term. Total term is, though it is infinity, so it won't matter. Though it's infinity, it won't matter. Okay. Now, how to go for it? I'll see this as n plus 1. ये क्यों है ना? Okay. So R0, I'm going to divide everything by, so I can take out n cube here. And this will be 1 plus r by n cube into n square. I got the thing. So sigma dx upon 1 plus x cube. Very easy question. Limits 0 to 1. Won't matter n or n plus 1. But you must remember that n plus 1 is there. Total terms are n plus 1, not n. Though infinity plus 1 is infinity only. Now part E, again I can write it. I see sec square everywhere. I see 4n everywhere. What is changing is the coefficient of pi. And it's changing from 1 to, it's easy now, 1 by n अपने आप बाहर separated है. So I can write r by n, pi by 4 r by n. So pi by 4x. Sec square pi by 4x is tan x. And the limits basically becomes n 0 to 1. Clear? Question number F. Now I see n everywhere down. I see 4 by n, 8 by n, and probably the last term was 4 into n by n. So the story started with 1 by n and ended with, so I can say the general term as 1 by n into e to the power 4 r by n. Limit goes from 1 to n. So I can say sigma 0, 1 e to the power 4x dx. Very easy, right? Similarly, I can handle g, I can handle h, right? H ho jayega. You just have to recognize the general term. So h tak, no problem. What about j? What about j? N factorial upon n, n, which I can say that 1 into 2 into 3 to n minus 1 into n. यहाँ तक आ रहा है और सबके साथ n है, right? सबके साथ n है, यही मतलब हुआ. And it is 1 by n. I can say this is equal to L. I can take log 1 by n ln 1 by n plus 2 by n. ऐसे ही होगा. Sorry. Log a, log ab is log a plus log ab. ना? तो sigma log r by n. R goes from 1 to n. To the power 1 by n. This is equal to L, log L. I can calculate the left hand side. How? 1 by n है ना? ठीक है. Log 1 by n plus log 2 n. ठीक है, ये हो गया. तो ये basically हो जाएगा 1 by n. So now it's fine. It is 0 to 1 log x dx is equal to log L. Do not forget to replace the answer by L, right? See, so whenever you see product, think of log. You see J part, R is approaching from 1 to 4n. 4n है, तो limit पे ध्यान रखना. Everything remain the same story. Down. K is fine. Under root 4n square minus r square. I'll take n square out, n out. N out. So 1 by n is there and r square by n square there. So these are very easy question. L you can easily handle, right? The next sheet. So we'll discuss the property now. Okay, just spot the error. We'll just develop something. We will just say that when I say a to b, the basic definition is very important. When I say AB fx dx is integrable, it means it has to be continuous between A to B. We can say only when it is continuous between A to B. Let's say if it is continuous between A to, so how to handle it? When this is the scenario when A to B are in closed bracket. When this scenario comes up, you will say limit x approaching A plus FB minus limit x approaching A plus FA. Right? When the scenario comes out to be AB, it will be limit x approaching B minus FB minus limit x approaching A plus FA. Clear? सेमी क्लोज में दोनों केस में ये हो जाएगा अगर B clear, getting the idea? तो ये लिमिट्स हमेशा लगाना. Okay. Now while doing the substitution, one thing which you have to keep in mind that when we are doing the substitution thing, which we have been doing in definite integration, we were not careful about it. We were just putting the substitution thing, right? But in definite integration, when we are going to substitute, we have to make sure the function which we are substituting has to be a bijective function. What does it mean when I say bijective function? It has to be 1, 1 and onto. That is bijective function. The second most important thing, the substitution which we have to do for that period, A to B, that has to be continuous as well. That has to be. The first question is asking you to spot the error. I say 0 to pi sine x dx. If I say this is the answer and this is surely be 1. This is 1, right? We know it. The area of this part is 1. But the answer, when I substituted with sine x is equal to t, I got cos x dx and my dx became dt. Then why the answer turned out to be 0? Because we are replacing sine x by t. So this has to be taken care कि 0 से pi के बीच में whether this function is bijective or not, right? So yes, the mistake was that we took t as a bijective function. अगर 0 से pi by 2 होता, things would have been no problem, no issue in substituting, right? The second part, you see that limit goes from 0 to pi and I see dx upon 1 plus 2 sine square x. So I'm going to make it sec square x dx upon 1 plus 3 tan square x. So now my substitution tells me that t is equal to tan x. The limit goes from 0 to pi and I'm substituting tan x by t. What's the error? From 0 to pi, tan x is bijective, right? Tan x is bijective. Huh? है ना 1 1 1 1 है ना. But the issue here is it is not continuous. It breaks at pi by 2. So that is why error. Okay. So integration में you have to be very careful about the continuity. You have to be very careful about the while substituting, you have to take care of two things more. One, continuity, and the second, the bijectivity, right? Over that limit, whatever the limit you have calculating. It doesn't mean that whenever you see you're thinking that I cannot substitute because it will be, but you have to be very sure that that particular function is 1 1 and the continuous thing. Now see, the deep C part is also the same issue, right? 0 to 2 pi, I did the substitution tan x by 2, big mistake, right? सारी चीजें मैंने flop कर दी. The part D, okay, what about D? What is the problem here? I did everything fine. D, I didn't do any substitution. I just did x to the power minus 2 to the power minus 2 dx. At x is equal to 2, the function is breaking. It's not even defined. So how to go for this question? I have to take 0 to 2 and then 2 to 3. And at 2, we have to find the limit. Getting the idea? Question number part 3. Okay, the properties, we'll start fresh tomorrow, the properties, right? So any problem? We'll just recap how things were like. We started defining the definite integration as a machine which calculates area. Okay, and then we were very much happy at the moment the functions were linear. We were able to find the area. But the moment it became curvy, we thought of circle. And circle, with the moment I saw the area of circle is pi, I was secretly speaking the language of limit, which we were not knowing, right? We have been using it from class 6, 7, but we were not knowing that actually we are talking about limits. And then we tried exploring that limit part into the curves. We started fragmenting it. What I said, that larger and larger number of smaller and smaller local values, larger and larger number of smaller and smaller values, and adding up to get a global sum. That was the idea. So we broke it, and then we derived a very amazing equation of Riemann sum, the left hand side and the right hand side, underestimating and overestimating. And the moment we got the Riemann sum, we actually defined what is a to b fx dx mean. It means it approximately equal to that Riemann sum, right? And then we got the definition, and then we got into the Riemann sum, and then we saw that it's very ugly. X square is fine, x cube is fine. Then after that, things will be very ugly. It will be very difficult to add things up. So we thought of accumulation function, and then accumulation function came to our rescue. And then using the accumulation function, we defined accumulation function as 0 to x ft dt. And we know that accumulation function increases if ft is positive and decreases if ft is negative. So we see a correlation. And then we got that, okay, my accumulation, that I defined my accumulation function, and then we found fb is equal to a to b fx dx. And then we got the antiderivative of fx is gx. And then we saw the relation between fb and gx, fx and gx, that is fx is equal to gx plus c. And then we know that fa is 0, so we got that, okay, c is nothing but minus ga. So we got my accumulation function fx as g of x minus ga. And when I say fb, it means g of b minus ga. And then we also learned how to differentiate the function when we see the limit as of some function of x, right? We saw it in the last part. Tomorrow we'll first discuss the properties, all the properties, we'll do all the sums, and then we'll discuss that differentiation part in the later half. And maybe if we get the time, we'll try to discuss the IIT JEE questions. Okay, and then next class we'll discuss, after that class we'll discuss application of integration, that is area under curve. Okay, okay then, thank you.